And we got like big one right from the start from Check the Fox Author. Check the Fox Author is asking, can you rant a bit about spatial variables? I already have a lot of potential use case ideas, but I'm curious what applications you see for them. So spatial variables, for those of you, I'm gonna put this here, I guess. For those of you who don't know, it was a planned feature that was kind of separate. It was actually on my list of like things I really want to add because I feel it's a very powerful system for creators. It can open up a lot of new options. I really wanted to add it. And it's also like not very big, like implementation wise. Like there's not super much, that it needs. A lot of the lot of building blocks are kind of already there. And when I'm working on the audio system, I needed a system, for the audio listeners in the scenes to figure out like what audio effects, specifically what the reverb effect is available in certain area, and then blend it. And to do that, I would have to implement a system that would be kind of like spatial variables. And I had two choices. I could just implement one that's specifically just for reverb, specifically for audio. That's the only thing it can be used for. Or I could generalize it and just use spatial variables. So I was like, let's get like, bigger bang for the buck. Like, let's get more out of the time I invest into the system. And I'm just going to implement the spatial variables and then use it for the system. Who would think you... I don't know what it was. Oh, Nikicon's writing again. Interesting. I don't know we can do that. But yes, what spatial variables are is like you can essentially define... I'm actually going to grab my brush. Where's my brush? They allow you to define values in space. And it happens in 3D space. I'm going to draw it in 2D to make it a little bit easier to understand. Let's see, where's my brush? There's my brush. So imagine like, you can literally say, okay, at this point in space, there's a value. Like, this can be a sphere. In this case, it's a circle because 2D. So like at this point in space, there's a value, and maybe there's a different value over here. And maybe there's another one here. There's like a cube. And say like this is just a color or floating point. It can be any type of value, like, kind of similar to dynamic variables, except instead of them being bound by hierarchy, they are bound by space. So like when you want to sample spatial variables, you literally just say, I want to sample what value is at this point. So say like this sphere has value, 10, this one has like 5, and this one's 3. And by default, it's 0. So like if you sample here, like, you sample here, you're gonna get 0. If you sample here, you're gonna get 10. And actually, let me make this overlap as well so I can show you a thing. If you sample here, you get 5. If you sample here, you get 3 during the whole volume. And the interesting thing, for value, for like numeric values, you can also determine how they're combined. So for example, if you sample here where there's an overlap, depending on how you sample it, like you can configure it, you can have it the values together. So if you sample here, you'll get 15. And I just realized I'm drawing everything backwards for you. 15, 10, and 3. I should like undo this. There we go. Yeah, there we go. So now it should be the right way. So you can, sample here, you get 15, or maybe you say, I want this one to have higher priority than this one, and the high priority one wins, which means like if this one is high priority, you get 10 until you move here, and then you get 5. Or you like, so like, or you can, for example, say you want to blend between them, so you get like, something like 12, or something depending on where you are specifically. So it kind of interpolates based on, how far you are from each. So that's like, the kind of the gist of it. It's like you literally can define values in space and then be kind of combined, in different ways. And the value can be anything. Like here, this is the number, but it can be a color. It can be a spherical harmonic, if you want to like do like ambience. It can be a reference to a texture or like, object or something. You have like lots of, pretty much like any value that works in Resonite, you can make a spatial variable out of it and then sample it. They're also named, so you can like, these need to be like all have the same name, so you can have like a bunch of different ones that each has a different name and they're kind of separate from each other. Another cool thing with how the system works is, in this example, I made the values be constant. But you can actually also have the value vary throughout the shape. So instead of, let me actually just remove some of these to make it a little bit clearer. Actually, let me just clear this out. I'm just going to redraw everything. So say, there we go. Say you have the sphere. So even when the value is constant, one of the things you can do, you can say like, the value is going to be 5 throughout the whole sphere. You can actually define a region where it blends. So it can be like, there can be like a region. And if you sample here, so say the value is, 5. The value is 5 throughout the whole thing, but there's like a blend region. So like if you're here, you're going to get 0. And then here you're going to get, 5. And I kind of want to add a brush that lets me reverse things. Here you're going to get a 5, and you're like in the middle, you get like, 2.5. So like it's like, a smooth layering between the two. And it's actually how the reflection, not reflection, reverb zones are going to work, where, there's going to be a sphere which defines a reference to the reverb effect. And then the blending area is going to be fed into that reverb to determine how strong it should be. And, and it's like how the reverb zones are just a specific use case of spatial variables, but you can use it for anything, any data type, anything you want. So blending is like one of the things you can do, like, for example, with constant value. And if you have like, if you have like multiple of the spatial variables overlapping, the blending can be combined multiple ways. If you're adding the values together, you're literally going to be like, if it's 2.5, it's going to be 2.5 plus whatever else is at this point. You can also say the higher priority wins. So like if you have like, 2 regions, which have like both like blend region, then if you're like in the overlap, then whichever one has like higher blend is going to have higher priority and going to get that value. You can like, do average, like weighted average of the values. So like it's going to average them out, like, so you're going to get one that's like blend of all of them with the weight of each value being determined, by the blend. But you can also, separately from the blending, you can also define, that the value actually changes. So you can, for example, say right at the edge of the sphere, the value is going to be 10. So you're going to get 10, and let's say here it's going to be 50. So as you sample through that volume, here you're going to get 10, here you're going to get like, halfway between 10 and 50, which I don't know, it's 30 something, I guess. And here you're going to like, get 50. And there's also a bunch of different shapes that define, different ways to vary the value throughout the, throughout the thing. So for example, like there's also like a box spatial variable, and this box spatial variable, it also has like a blend region. But also like, there's multiple ways. Like there's like, I've already implemented one which uses a 3D texture. So you can use 3D texture, and the value you get is literally the value from the 3D texture wherever, wherever that box is. So like if you have a texture, that's going to give you the value. The other one for box is, there can be a gradient. So like, for example, and the gradient can be aligned certain ways. For example, it's this way. Maybe say, here it's 10, and here it's going to be 50. So there's lots of ways we can like, make different shapes that change how the value, they actually change what value you get throughout the specific shape. And it's on top of like, having multiple shapes that can overlap with each other, and give you like stuff. So that's kind of the gist of, what spatial variables can do. But the other part is, how can you use them? There's already like the example I've given with, with the reverb zones, and it's one of the kind of like excuses I've used to like add it. But there's lots of different use cases. For example, like say you want to do environmental effects. You want the ambient lighting to change based where the user is. This makes it super easy, because if you have a world, maybe say like you have a region here, and this has like bright lighting, outdoors lighting, and you have like a room here, and you say the room, this is darker lighting, and you give this a higher, maybe a higher, priority. So like when the user is in blend between the two, this one ends up winning over this one, even though they overlap. And maybe there's like, maybe there's like a super dark room here, so you put one here, and maybe there's like, a region here where you want different lighting, and you just define these spaces, and then you sample whatever, say, spherical harmonic you get, depending on when the user's head is. So say as the user is walking around, you just keep sampling, and you literally just drive the ambient lighting of the world where the user is, and you don't need to worry about any spatial queries. This system, it uses the Beppu acceleration structure in the background, which makes the queries super fast. So as you move around, you just keep getting different values depending where you are. So you can use it for environmental effects, and it doesn't have to be just ambient lighting. It can be, for example, sounds. Like you want to like modify how loud some sound is. Like say like you're making a club. You have a room, and maybe there's like speakers here. There's like speakers, and you want it to be quieter here. There's a room. So like if the user is here, there's a spatial variable that says, the volume of these should be really, really high. But once you get into this room, you want it to be way lower, like even lower than, the distance attenuation would make it. Or maybe you want to blend it into like a muffled version. You have like, a version of the track that's kind of like, like pass through a low pass filter. And once we also get like low pass filters, so you can do it in real time, you can feed that into the low pass filter. We can have a value that feeds it into the low pass filter and automatically blends the effect as you kind of move around. So that's another thing you could do. You could have like, it can be literally anything in the world. Like, say you want to change the lights in the world. Or another example, you want to do culling system. You can literally define a bunch of shapes in the world, which essentially say the user is the user in this room, is the user in this room, and then you just derive the Boolean of like, different places based on what value you sample where the user is, and then like you enable and disable different parts of the world. So culling system is another great example. Another cool thing is, say you want to make interactive systems that are very interoperable. Say like you make something like a torch. Make a torch. And then like you have like, somebody makes like a fireplace. So there's like, a fire. And what they do is they can define this as a spatial variable named fire or hot or whatever, you want to do. So there's fire. And make sure you duplicate this one. And this torch, it samples spatial variable, at its tip. And if it detects that fire is above a certain point, it will activate itself on fire. And then the user all needs to do is just put in their fire, and now it works. And if you have worlds where people set up, spatial variables with this, now those are all interoperable. You don't need to do anything extra. You just say, what is the value of fire at this point in space? And if it's above a certain point, like I'm gonna set myself on fire. And even cooler, you can, have the torch have a spatial variable that's fire, and once it's on fire, that's also gonna output, that it's on fire. You put it next to another torch, and that's gonna set it on fire. So like you can have systems, interact with each other without having to like, manually sort of link them together. So it like allows for a lot of like really cool kind of spatial interactions like this. Another cool thing is, you could, for example, you have worlds where you want to determine, like you have like when to switch to a swimming system. So like you have like, you have like, say like a pool here, like, there's this pool, and there's like, some water around, so like this is a beach and this is the water. So you just say this is spatial variable, water, for example. So you're just gonna sample what is the value of water here, and maybe there's another water here. So there's another water, and if you detect it's above a certain point, you switch on a system. Once it goes below a certain value, you switch the system off. And it becomes as simple as, as just driving a value from a specifically named variable. So there's a lot of like and this is just kind of scratching the surface. Like, I think like once this is like added and everybody can like work with it, it's gonna be huge. Like, it's gonna make so many systems much easier to make and make them much more interoperable with each other. I've already seen like people were talking about like, making standards for like, common things like, water, witness. Another thing, you can make a thing on your avatar which just samples, what's the amount of water. Once it crosses a certain point, maybe you trigger effect which makes your avatar look wet. Like, so like, and that helps like enhance realism. You go into the water, your avatar is wet, you step out, and maybe like, your wetness drops. I've already seen some people kind of use that kind of system, but there's not really a way to make it like very interoperable with things, and this system makes that much, much, much easier. And I think like a lot of once you're able to play with it, which you'll be able to very soon, people are going to discover even more like really cool like use cases for it, and probably a lot of cursed ones too. Christians are going to get like
gravity.
Oh yeah, like, that's another thing. You could literally just say, define a spatial variable that just is a vector, and like, is like this is the gravity that should be here. So like if you're here, maybe the gravity is down, but like once the player's here, the gravity is maybe this way, and it's just like it makes the setup so much easier because like all you do is just ask what is the float 3 at this point of name gravity, and once you go to here, you get a different value. You just drive whatever thing on locomotion module you need, and it just works. It just works.
Yeah, you don't gotta do math. You don't gotta do a bunch of math to do it anymore.
Yeah. It makes a lot of things like way simpler for like interoperable systems, and makes it much faster because like this is the acceleration structure. So there's a lot of like use cases for this, and I think there's gonna be even more like once you get your hands on it. I think it's gonna be like very, very powerful system, like kind of like on the level like like when dynamic variables were introduced, that kind of changed a lot how people build things, and I think this is gonna be another really, really good tool in the creator's toolbox that's gonna make it easier to build things and make them more interactive and more interoperable with each other.
Oh yes, I'm very excited. There's like so many. I was talking with like Jack earlier today, and he was like, these are like so powerful that like there are things that like I don't even know I could do with them yet. I'm sure, like there's so many. It's just such a broad use case that I don't even know what all they could be used for, and I'm eager to find out.
I really like these kinds of systems because it's like it's been relatively simple to implement. It took me like a day or two, I think. I haven't like super explicitly tracked it, but like it didn't take like super long time, and it's like such a simple system, but like so powerful. I feel like the 2 days, like it was kind of made easier because I had to like generalize some. Like I made essentially a spatial collection built around the bedproof physics because it's also used for some other audio stuff, which makes it easy to just say there's like this object and it's like in this space, and I can sample like I can do spatial queries very easily. So there's that made the implementation also like kind of quicker because I had to do that. But also that wasn't super big thing because there was already part of a generalization that I did for the dynamic bones a while back. So it's just kind of building on top of that. I was gonna say another thing, I forget what it was. But it is gonna be like I think very like game-changing system for like building a lot of things on Resonite, and that's kind of like one of the reasons I was like I should just implement that one because that way like like I can use it to make the reverb zones. So it's something I needed, and usually when we build things for Resonite, we kind of look how do we implement things in a way that like it's not just that one particle system. It doesn't have just that one use case, but it has like a million other use cases, and it was like a perfect opportunity to do so. And that way like we get like much more value from the time because like our time is very limited on what it can do, and there's something of that value that we can do like to like supercharge like the power to have like to build things on Resonite, like we want to do it. Another cool thing is like there's also another sampler that I added, is like a Boolean sampler, so you can, for example, say, I want like this Boolean to be true if there's any true value, like, in the space, or if all of them are true, or if, like, none of them are true, or even do like XOR, like exclusive, like OR, so like each Boolean potentially flips it. It's like, that space. It can also be used for other cool things. Like if you have like, overlapping region, so say like you have like here and here, which can be useful, for example, for the culling, systems, is like, you're gonna get through in all of this.
Spatial hashing.
Spatial hashing, oh my god. But yeah, it's I think it's gonna be like pretty big, and I can't wait like what people will make like once you get your hands on it, which would like probably tomorrow, maybe tomorrow's Monday. Yeah, probably tomorrow, like on the pre-release build, because I'll have a pre-release build for more testing for Awwdio, which is another thing, but I've already did a ramble for it. But yes, spatial variables.
A pre-release just for us.
Yes. Well, it's gonna have like other Awwdio soon, audio-based, because like I did rework a bunch of things, so that needs to be testing. But it also has spatial variables, so you'll be able to play with both.